Long eagerly is to grow and deal of knowledge. I now request Dr. Ganesh Khekare to deliver the address. Dr. Ganesh Khekare is currently working as an Associate Professor in the Department of Computer Science and Engineering at Vellore Institute. He has done a BE, ME and a PhD in Computer Science and Engineering. He is a postdoctorate from the University of Lincoln, Malaysia. He is UGC NET exam qualified with 98.5 percentiles. Recently, he received the most prestigious IER Young Engineers Award. He has been a member of different societies and professional bodies like ACM, a lifetime member of the IST, IEI, ISDS, and IEEE senior member. Kindly deliver the address.
So, good morning, all. Yes, last benches, good morning. So, we will start. What do you want to learn? So, somebody is saying nothing. So, he comes under my category. Okay? So, now, as the theme has been given of a smart agriculture for this event, I have come up with my presentation. So the today's my topic is technological advancement in a smart agriculture in AI and so what is the role of AI and ML in a smart agriculture? I am going to focus on that. Okay. So lot of technologies we have and technologies are booming nowadays. But as technology is booming, what is the use of technology? If you are from a farmer background, you might have seen we talk about a lot of technologies over here, and when we go to the farm, nothing is available on the land. If you talk with the farmer, nothing is available. Still, farmer suicides are going on. Why it is so? So technology is booming, technology is advancing, and still we are lagging. So what is the communication gap we have to convert our technology into a farm? How practically on the ground we can use that technology that is lagging over here. So one by one, as it has been told to me that the listeners are from UG, PG and PhD background. So today I will focus, after my session you will get a lot of project ideas and I will try to touch and various AI ML algorithms are available. Various AI algorithms are available. Which algorithm is to use? That is the main problem. Sir also given you practical knowledge of various things, various algorithms has been explained and practical demonstration also shown by the videos. But which algorithm is to use for which application, that is the major concern. Okay, if you are using classification models for the regression, it won't work. We have reinforcement learning algorithms, advanced like XGBoost, Q-learning are available. But if you are not applying that algorithms on the proper place, it will not generate you the result. Again, while generating the results, you might come across the concept between overfitting and underfitting. So our result always lies between 0% to 100% in the probability of 0 to 1. So if you are getting accuracy of more than 99%, then also experts will ask you, is it moving towards the overfitting? What is overfitting? What is overfitting? So overfitting is like that. If you are giving the entire data to your model and it is giving, see what is the difference between classification and regression? In a classification, you have the answer available in the forms of yes or no, true or false, girl or boy, cat or dog. But what is the regression then? In some cases, we don't have solution available. For example, can anybody tell me when rain will come next time? Next rain, when it will happen? How the stock market will perform tomorrow? Share market will go up or down tomorrow? Whether the India will win the next match or not? So here we have the probabilities. Perfect answer is not available in terms of yes or no, 0 or 1. So here we need to use the regression models. Okay. So this is the difference between the classification and the regression model. So where there is a probability, most probably we go with the regression model. Otherwise, we go with the classification models. So this is the basic difference we have. Again, we have the algorithms like supervised, unsupervised, and reinforcement learning algorithms. Can anybody tell me the difference quickly? Supervised, unsupervised, and reinforcement learning algorithm. Some books are come up with semi-supervised learning algorithm also. Okay. So what is the difference between these? Yes, anybody? So if you see, like teachers are standing over here, teacher taught you, teacher gives you the notes, teacher gives you everything. Okay, you prepare for the exam and you give the exam. This is nothing but the supervised learning algorithms in a simpler words. Teacher is available with you. Now what is teacher as far as our branch is concerned? So we have, whenever we apply any algorithm, we have the data set. We have the data set, we have the target. Just now sir has shown us the video. So targets are available to evaluate with the sir. So how model needs to be trained? So we require the data set. Okay. Now data set may be labeled or unlabeled. What is the meaning of labeled data set now? Let's take an example of Excel sheet. Headings are available, column headings are available. It is nothing but the label data in the simpler form. Okay. So in a supervised learning algorithm, teacher is available with you. In a technically it is called as a label data set. Okay. The second algorithm we have is the unsupervised learning algorithm, where you have unlabeled data set available. Teacher is not available. Okay. You will try to learn. Some dummy data set will be provided. On that basis, model will try to learn. The next we have is the reinforcement learning algorithm. Nothing is available. Nothing is available. We need to learn entire environment on our own. Okay? No one knows what is going to come. So as far as robotics are concerned, so we have the field of robotics. As far as robotics are concerned, we are trying to have reinforcement learning algorithms into a picture. So what is the role of reinforcement learning algorithms? That will learn just like a robot. We are trying to create a robot which can mimic like us, which can do the works like me. If I tell the robot to deliver the lecture on this topic for 2 hours, robot should be able to deliver on its own. Okay? So it has to learn the environment on its own. If I am telling the robot to identify the student who is talking, or identify the student who is using the mobile phone, and let us take this is the robot available with us. So robot every time doesn't know what is the quantity available and what it needs to be done. Okay, so that's why in reinforcement learning algorithm, whenever new case will come, it will identify on its own and will try to get out with the answers or the probable solutions. Okay, so with this basic difference between supervised and unsupervised and reinforcement learning algorithm, we will move ahead. And again we have machine learning and artificial intelligence. Okay, so what is the difference between ML and AI? Anybody? What is the difference between machine learning and artificial intelligence? If you are the UG student in a placement drive, a simple question will be asked you. Differentiate between data science, deep learning, data analytics, AI and ML. And just like this, we are unable to answer. And we are learning the subject thoroughly, and we are scoring 90% marks in the subject. But when the basic questions will be asked, we are unable to answer. So yes, anybody, the difference between ML and AI? So the terminology artificial intelligence has came into existence. The way we think, our machine should also think in the similar pattern. Okay? The way we think, decision making has came into existence with the invention of the AI. I am telling the word decision making. Machine learning algorithms are not as good as to make the decisions. Suppose my robot is doing the operation, and in between the operation, just like a doctor, if any new problem has come up after cutting the body, then how you will, machine learning algorithms will fail over there. That's why we have artificial algorithm. After cutting the body, if any new disease will come into existence, your robot should able to operate that disease. Okay, that's why artificial intelligence will come into existence. And listen to my lecture carefully. I assure you that whenever you face the placement drives or the technical interview, these kind of questions will be asked. Okay, now moving ahead. So the today's topic is related with the smart agriculture. So you can see what we can do. And again, the problem definition will remain same. We will talk too much about the smart agriculture, but on the field, especially in India, we are lagging to transfer our technology onto the field. So communication gap is there to transfer the technology and reach towards the farmer, and government is continuously working on it. So you can see for various agriculture works, now we have started using AI ML. Okay, and in foreign countries, it has been used. Okay. So various problems, whenever you use the machine, we require, if larger space is available, then machine can perform in a better way. For example, let's simple example, mechanical example of JCB. If you are telling the JCB to work on this 1 feet only, so the performance will degrade. So with respect to machine, if larger area will be available, then machine will perform in a better way. So artificial intelligence is a branch of computer science which has been used to perform the technological aspects. So one by one we will see how we are using AI ML in the smart agriculture. So you can see in agriculture revolution, so by 2050 we are going to reach 10 billion population throughout the world. Okay, currently we are on 7 billion plus. So to handle, to feed such a huge population, and again, as you have seen, the land is getting, farmland is getting smaller and smaller. Industries are increasing, population is increasing. Vice versa, production of food is decreasing. Because commercialization is happening and most of the area has been occupied by the industries earlier or the buildings. Okay, so the land area is reducing, food production is reducing, but the population keeps on increasing. Okay, so how AI is used in agriculture? So we have automated farming activities. One by one we will see all the points. Then identification of pest and disease, where we can use. See, what is the problem with the farmers is that they come to know that any plant disease is there after it has been occupied by the 80% crops. If you identify the crops before it comes, any disease, any plant disease, okay, if you are able to identify any plant disease before it is going to come, then it will be helpful. Okay. So after, for example, if you are a student and after failing in all the subjects, you come to know that you haven't done the study, it is of no use. So that's why different unit tests are kept to identify your evaluation. And the third thing we have is the managing crop quality, then monitoring biotic, then abiotic factors and stress, and machine vision systems. So one by one we will see this. So this is the one photo of a smart agriculture irrigation system has been given, which has been implemented in the VIT. The next we have the effect of usage. Now, whenever you deal with any equipment, AI ML based, again one major factor is the costing. Major factor is a costing. If you are telling the farmer to buy a machine which will be helpful to him or her, who will give the money? They don't have money even to feed themselves. and you are telling them to buy a machine of 10 lakh rupees. So it is not possible. So you need to focus on reducing the cost of all the equipments, then reducing the cost of production. Whatever the vegetables you are creating, you need to focus on minimizing the cost. Then maintaining average vegetable yields, then minimizing the environmental impacts. Okay. So whenever, and in India, especially in Chennai also, anytime rain comes and flood-like situation is there, especially in Chennai. Okay. So how you are going to tackle this? So we require, while dealing with the climate also, climate being also, we require such a solid system which will tell you that after 3 days rain going to come. Okay. Then we have labor cost. As far as farming is concerned, labor cost is too much. Okay, and even machine is costing much more than that. So we have substantial water saving compared to irrigation management. Now the next we have what are the problem statements available with this. So a lot many problem statements we have. So just now I have discussed with you climate change. Any time climate will change and it will affect the entire, whatever the crop or the yield you have, it may affect. Then second you have water problem. Water problem. Now as far as water is concerned, irrigation problems are there. Any time rain comes and rain comes in a large extent, sometimes dryness is there in the rain also. So various factors are affecting it. The next we have is the traditional irrigation methods. So a lot of problems are there in the irrigation method. See, whatever the irrigation systems are available currently in our farms, that are not technological based. Getting, we are not identifying what amount of water crop is required. First, we need to analyze what amount of water crop is required, and with respect to that only we need to provide the water. Sometimes our farmer go to the farm at the night on the motor and it will be on throughout the night. Water is also wasted in this case, energy, electricity is also wasted, and too much water will harm your crops as well. So that's why proper management is needed. Again, if you are going with the sprinklers, then proper management of sprinkler is also required. Most of the time uniform distribution of the sprinkler throughout the agriculture area is also one of the problem definition we have. Then lack of real time data. Just now example I have given to you. What amount of water is required to a crop? With respect to that, give that amount of water only. We don't have that much sensors available in the farms. Then again, real time data. So whatever the scenario is happening, real time data should be provided to you. So when proper amount of level of water has been reached, then alarm should go to a farmer that motor needs to be switched off. Or we can go with the automatic water treatment as well. Then we have climate variations demand dynamic climate smart irrigation technology to sustain. And the next we have is the drip irrigation. Now what is drip irrigation? Drop by drop, rather than giving too much in a one go. But in that also we have a lot of water has been wasted because it is for 24 hours it will be on and unnecessarily water will be wasted. So some mechanism needs to be there where we need to stop it. Now, why AI ML model are used as far as smart agriculture is concerned? So it enables real-time water management. Okay. Second one, it predicts precise irrigation needs. Then it controls and monitors the water usage. Then climate forecasting also needs to be done. Then forecasting of water requirement also needs to be done. Then with respect to the crop requirement, we need to give the water and then process complex data for adaptive, sustainable and precise water management. Now what is the difference between this adaptive and sustainable? Adaptive and sustainable. Adaptive means you can adjust to any environment. Okay, and sustainable means it should sustain for a longer period of time. Whatever the technique you have, it should sustain for a longer period of time. Now, various limitations, if you go across various research papers, these are the problem definitions you will come across. Most of them we have already covered. Okay? Insufficient. Now, AI IoT integration. What is IoT? Yes, somebody is saying Internet of Things. Have you heard the name IoT? IoT, you might have heard, Internet of Things, and I have seen one branch also in your college, IoT branch. So, Internet, but what is IoT? So, IoT is just like one more step ahead of IoT. IoT is the Internet of Things. So, when I say things, it will be the integration of various sensors, devices, and everything. But when I say Internet of everything, then human body is also treated as one of the thing. Intelligence has been provided to it. People, process has been come into existence. So the integration of IoT, IoE needs to be done. Okay? How IoT works? Continuously sensor will detect the data, and with respect to that it will work out. If you have gone in the big malls or airports, glass door is there. It senses the particular person and doors opens and door closes. Now we have come up with a home automation system also. If person is available in the hall, light and AC will become on. If person is not available in the fan will become automatically off. Again we have with fuzzy logic we have gone one step ahead. The number of persons sitting in the room with respect to that AC level will be adjusted. So such devices are already available in India as well. Now, to do all these things, various models available. Okay. Now, whenever I say model means it is made up of algorithm. Okay. So as I have told you earlier, through this lecture I am giving you various problem definitions available in the as far as smart agriculture is concerned. And at the ending I will also tell you what can be done and what algorithms you can use to solve the particular problem. So you have machine learning models like random forest. Most of the names you might have heard, as all the students are UG or UG onwards. So random forest algorithm, then support vector machine combined with IoT, then decision trees, gradient boosting, then MPC. Okay. Now, whenever you apply any algorithm, thousands of algorithms are available. Which algorithm is best? How you will identify? So, whenever you take a research definition into account, whenever you do a major project, so in that major project, your teacher will ask you what is the novelty of your project, what is the data set of your project, and how you can tell your algorithm is the best one. So, in order to tell whose algorithm is best with respect to scenario, we have various parameters are available. Right? Have you heard the name root mean fair error? Then F1 score is available, recall value is available, AUC value is available. So these are the different parameters through which you can compare different algorithms on a single database or the variable complex data set. The next one, in the earlier session also sir has elaborated you the neural network. Now neural network are also of different types. Convolutional neural network, recurrent neural network, artificial neural network. So different neural networks are available. Now, after applying these algorithms, some of the algorithms I have put in. So you can see whether it is a water usage or whether it is a crop yield or it is a prediction of trace or it is a water management. Up to some extent, it has been improved. Okay. And extension, you can see an accuracy of model. Whenever you get an accuracy of 90% or more than 90%, then only we can tell the algorithm is performing well as far as whatever the problem definition has been given. So you can see this graph. So prediction has been improved by applying various algorithms in that range. Now these are the existing models. How? Now every time question will be asked, whether you are a UG student, PG student or PhD student. What is the novelty of your algorithm? If you are telling, I have applied XGBoost algorithm for my project. So what teacher will tell you? What new you are doing? So how to come up with the new algorithm? How to come up with new algorithm? Simple example I will give you. Everybody might have learned the subject data structure. In the data structure, various searching and sorting algorithms are available. How searching algorithms work? Somebody do the search from left to right. Somebody do the search one to one. Some algorithm will do the searching from right to left. Or we have algorithm like binary search or bubble sort, which divide the complete data set into two parts. Due to that complexity, time complexity also becomes divided by 2. Okay? So, the first step while doing any research work, whatever the well-known algorithms you have, you implement that well-known algorithms. Okay? And after implementing 3 or 4 well-known algorithm itself, you will come to know what is the problem they have in their method. While teaching the data structure subject also, you might have told, many times you told to your teachers as well while teaching, sir, why this simpler algorithm you are teaching to me? It is very simple and it is very old. So yes, that we need to find out. Once you learn the old algorithm, then only you will come to know what is the flaws in that. And then with respect to that, you can modify your algorithm and you come up with that will be called as a hybrid algorithm. That will be called as hybrid algorithm. Or if you are inventing your entire new algorithm, then only it will be called as a novel. Okay? So, as I have told you, still reinforcement learning algorithms are not frequently used as far as smart agriculture are concerned. We don't know what. See, if you are identifying the diseases, plant diseases. So now some diseases are available, but it may happen that after 5 years some new diseases will come. Then your supervised algorithm and your unsupervised algorithms are unable to identify that new disease. But if you are using the reinforcement learning algorithm, earlier I have told you, reinforcement learning algorithm learn the environments on its own, and if any new atom will come, it will provide you the solution. Again, I will give you the simple example. If I have made the system to identify which is orange and which is mango. So for this problem, classification problem, supervised algorithm is the best one. But if any third fruit will come, then your supervised algorithm will fail over here. So if any new entry will come, in that case reinforcement learning will perform in a better way. So you can see, you can use hybrid AI IoT algorithm. Gradient boosting is there. Gradient boosting, Q learning, you can use XGBoost, you can use, which are based on reinforcement learning algorithms. Now, this is AI remote sensing crop health monitoring. So as you can see over here, this is the photo of a leaf. Now, if image is available, everybody knows how from image has been applied, how image has been extracted and algorithm has been applied on it. See, CPU only works, CPU only knows binary bits, 0 and 1. CPU only knows binary bits, 0 and 1. So we are taking the image, how this image has been manipulated. So have you heard RGB color? In the childhood, when we draw anything, so our teacher tells us the 3 basic colors are there. red, green and black. Sorry, blue. From RGB you can create any combination of color. So your whatever the image you have, it will be converted into a RGB image, and from that RGB image it will be converted into a grayscale. Now what is grayscale image? Black and white. Yes, correct. Black indicates 0 and white indicates 1. And with respect to that, probability has been created between 0 and 1, and various matrix has been created. Just like this is the image. So complete matrix has been created by using array, consisting of your 0 and 1 or the value between 0 and 1. So for converting this also, various image processing algorithms are already available. You can use any algorithm for that. Now conventional method, whatever we have, is the time consuming. Okay, any new complex problem will come, it is unable to handle that. Then 3D mapping, just now sir has shown us the video earlier session. So 3D mapping has been shown. Okay, how somebody has asked the question also, how geotagging and 3D mapping has been done. Now this is the transforming farming with advanced technologies. So we are trying to integrate robots into a farming, then IoT implementation, then the role of AI and ML, then modern agriculture, then traditional farming, and then data science applications. Why data science is required? Because a large number of data has been generated, and to analyze that large amount of data science is a must. Now, precision agriculture. So we have AI powered targeted spraying. So if any disease is there on the leaf, we need to go with the spraying as well. Then digital twins, in detail has explained this. Then robotics, then IoT and cloud integration, then smart sensor, and then autonomous meters. Now again, after IoT, we have come up with cloud integration. Why cloud is needed? What is the difference between cloud and simple client server architecture? What is cloud? Yes. See, cloud provides you the facility to access anything from a remote location. Access anything from any remote location. You can simply sit on any system, you just do a login and you can access your inbox, Gmail inbox, very easily. If you want to send an email to 500 students at a time, you can send it in one glass. So then we have precision agriculture adoption. So automatic mobile based water irrigation system is also available. When you want to give the water through your cell phone, you can give the command. For that period of time, motor will remain on, and after that it will be off. Okay. So that irrigation system through your phone, from your home you can access it, and it is available in India as well. Then we have a sector representation, then auto skipper usage. Now modeling solutions for better insights. Now the new terminology has coming up, agentic AI. Earlier we have generative AI, explainable AI. Now we are coming up with agent-based AI. Okay. What is the role of explainable AI? Generative AI will generate the data set for you, just like ChatGPT we have. How it has been generated, that will be told by explainable AI. And agentic AI, we will try to find out the new solutions on that basis. Then we have machine learning algorithm, and the third algorithm is already a well-known algorithm, just like support vector. So this is the newer thing, agent-based models you can use that can simulate farmer behavior and policy uptake. So agent will continuously analyze the environment, and with respect to that, it will generate the data set. Now enhancing data for robust AI. So you have federated learning is also there. Federated learning is also a booming thing. It is a subset of AI only. It is a subset of AI only, but additional security features are available in the federated learning. It enables model training across forms while preserving data privacy. Preserving data privacy. See, data privacy is needed everywhere. You cannot share everything with everyone. Okay? If you are going to hospitals, so entire data cannot be shared. Basic details you can share, but whatever the private data we have, like username and passwords, whatever the authenticate pins we have, that we can't share. Now, top AI technologies in precision agriculture. So we have reinforcement learning, federated learning, and you can use GAN as well. Now, digital twins has already explained in detail. Now we have IoE. So the difference between IoT and IoE I have already told you. When human input has a taken, person has a taken as an individual as a thing, then IoE will came into existence. And we have Edge AI. Now what is the role of Edge AI? So we have cloud computing, we have fog computing, we have edge computing as well. So in Edge AI, the decision will be taken on remote device itself. You do not need to send your data to a centralized server, and centralized server will not take the decision. On your device itself, most of the decisions will be taken. Now, pros and cons of precision agriculture. First point as your productivity will increase. You will use the equipment in a better way and better decision making will be done. Whereas negative points are it have a high cost, data issues, and then technological gaps and the scalability. Now, during implementation, we have various barriers are available. So we have strong yield gain, sustainable input use, but drawbacks also we have, as discussed earlier as well. If you are going with the AI ML technology, it is costing too much. Okay. Even Elon Musk has launched last month a robot has been launched, and from the next year it will be available for household use. Okay, and the price has been kept around $30,000. Now, key strategies we have. So interoperational device we require, then funding and training is required, and then invest in AI models. So as you have seen, every government throughout the world now focusing on the giving the funds to the AI model, then giving the funds for the quantum technology. Now, here we have technology and modeling and collaborative adoption, and we are trying to come up with a transformative impact. Another example, problem definition I have given to tell you the algorithms in a better way. So we have such kind of plants are available from which wine has been generated. Now, whenever we wish to generate the wine, or most of the plants are also used for creating the medicines. So the 2-3 factors are taken into consideration when we need to take that plants, so that the output will be generated in a better way. That you need to identify. Then second, in what proportion they are needed, that you need to identify. Okay, and for how much time you need to process it, that also taken into consideration. Now, climate forecasting, again various the difficult or the tedious topic as far as the smart agriculture is concerned. No one can predict when rain is going to come. And weather forecasting department tells us that tomorrow red alert has been given, on the same day no rain comes. Frequently this is the scenario. Okay. So why it is happening that we are not able to predict the weather forecasting? Because no one knows when the environment change, and it will happen suddenly. And whatever algorithms we are already applying, that is static in terms. It will take history data more into training. So that's why always it has been told that whatever the data set you have, always break your data set into three components: training, testing, and validation. So training is required to train your model. Testing is required to test what model you have created, it is generating the proper result or not. And then comes the final stage where you need to validate your results. And result validation is the most important step. So here you can say, so it consists of various factors. So like we have advanced climate prediction, you have different model AI forecasting, smart policy, adaptive planning, and at the end we have policy invention. And while they are using AI also, ethics needs to be followed. Okay? Ethics needs to be followed because whatever the technology you are coming up with, it may be bad or good. So you need to make policy making plays an important role over here. So this most of the factors we have already discussed. Now, key challenges in climate forecasting. So, climate forecasting, rain, weather condition, what amount of sun is going to come. So, various factors are there. So, carbon data sets are also need to be into consideration. And whatever the training you are providing, that sample size must be taken enough so that result should be generated properly. So underfitting and overfitting, both you need to take into consideration. So perfectly you need to train your model and you need to proceed further. So diagrammatically same has been explained. And again, when you are dealing with the IoT devices or IoE devices, the most important factor is energy. Okay? Because everywhere electricity will not be available. Most of you might be using smartwatches. Okay? So most of the sensors do not take AC current directly or not even take DC current also. So most of the IoT devices has a inbuilt battery available with them. So energy management is also one of the challenge as far as IoT or the AI devices are concerned. Now the role of AI with respect to digital tools. So multiple applications and we are trying whatever the devices we have, mobile phone, laptop, desktop, smartwatches, we are trying to provide the solution with the available setup only. Now the different methods are used for the climatical changes. So we have the tools available. Then public-private partnerships we have. Then millions mobilization devices we are trying to use and significant emission and then positive farmer income gains we are focusing on. Now the different methods are available. Then we have econometric tools, public-private partnership and GHG qualifications. Now GHG qualification is basically for measuring greenhouse gases. Okay. So we have come up with the concept of greenhouse in the various forms. You might have seen greenhouses has been created, and in that greenhouse also various parameters needs to be mentioned in a proportion. So where government needs to invest or we as a farmer or the individual need to invest, the first one is emission reduction, whatever the emissions we have, then crop adoptions, and then why we are doing this to ultimately increase the income of our farmers. Again, one more problem is there. Whenever you come up with a prototype, there is a difference between prototype and the product. there is a difference between prototype and product. Whatever major project you might have done, that is you have created a small prototype showing how your model works. Then that prototype will be converted into a product, full-fledged product, just like this remote control, just like mobile phone which you are using. And then another problem will come, the scaling of that particular mobile phone. So scaling means now product will launch. People started liking that product. People started liking that product, and immediately a demand has been increased in the market. So to fulfill that demand, you should capable of creating the production of that much products. Now the sustainable agriculture. So this has been already we have discussed. And as far as plants are concerned, the amount of carbon plays an important role. Okay, because carbon plays an important role as far as survival of the plants are concerned. And these are some of the solutions are here on which you can work out. Okay. Now, some of the recommendations from my end, you can combine AI weather forecasting with a farmer advisory system. You can also take IoT devices into a consideration. You can take various sensors into consideration and try to analyze what is the requirement of the plant. With respect to plant requirement only you can. Now, how you will identify what is needed to a plant? You can analyze the weather conditions, you can analyze the soil condition, you can analyze the water condition, you can analyze the leaf condition. And with respect to that, you can suggest the probable solution for it. So this is the smart agriculture transformation. So one example of a butterfly has been given over here. So So what disease plant is having? At the initial stage itself, your model should be able to identify what disease is going to come. If you target the disease at the first step itself, your disease will be neutralized within a day or two. Otherwise, it will create a big problem. Then integrated dimensions, we have data gaps and resilient systems we can use. And then we are trying to do the automation of the things. Why we require human input at every time? Okay. So we are trying without human input, everything should run. For example, you can give the farm area to a machine, and machine will give you the ultimate output. Okay, no human input. Whatever the machines we have in India, at every step human input is needed. Human observation is needed at every step. So we are continuously trying to move that. And two machine learning techniques also you can use at a time for self-organizing math and support vector machines. So this integration will be helpful. So this is one of the example. The model has been created in the VIT. So leaf disease, any leaf you can take, and as I have told you in between, it will be first converted into a RGB image and then grayscale, and then with respect to your algorithm, different steps will be performed, and we will try to get the ultimate output. And again, your model should provide what disease it has and how you are going to overcome it. Still, whenever we go to the hospitals also, we do a X-ray CT scan. Still, machine is not able to tell what amount of disease you have and what medicines you need to come. That X-ray and CT scan will be analyzed by the doctor, and then doctor suggests you the medicines. So smart agriculture for pest controlling. Now we will see the pest controlling, how it can be done. So we have predictive analytics, then real-time monitoring, then increased food security, crop health, and optimized control. So here you can see, as far as pest control is concerned, we have reduced yield and quality and various problems due to the various diseases. Production has been decreasing. So these are the various parameters we have. Now, as you are talking about the farm is very big, okay? And every time you might have come across daily in a newspaper, we come to know that farmer in the evening goes to their farm and various animal snakes are there, tigers are there, and due to that, various hazardous event has been happening. So we can have a use of drone as well. Drone technology is booming nowadays. Why to go in the field personally? Okay, if you have the robots, machines are available. So through drone you can analyze the conditions of your farm, and with respect to that you can take the decisions. Okay, and different algorithms are also available. Nanotech with IoT integration is also available. What is computer vision? What is computer vision or vision transformers? The way we see, in a similar fashion, our camera, mobile camera or the device camera also should analyze the things in the similar way, and it should take the decisions accordingly. Okay? So we see the scenario, and with respect to that in the mind, we take the decisions. So in order to see the entire area, we require a computer vision. And by seeing through the computer vision, then in the back end, we have AI algorithms are available to analyze it and give the decision. Then what is the role of IoT? See, these are, at a time you cannot go with one technology. IoT will work you, different sensors are available who will continuously provide you the data. And what is the role of AI? To take the decisions at the server end. So before it should happen, we are trying to neutralize it. Now, the next we have is the convolutional neural network. So whenever the convolutional network has been applied on the smart agriculture problems, it has been observed that very good accuracy has been given. Okay. So as I have told you, various parameters are there to measure your algorithm. So parameters like you have accuracy, recall, f1 square, then AUC is available, then root mean square error is available. So how this model will work? So this is the detection will be done by applying image processing algorithm. Then data augmentation will be done. Then convolutional neural network is available. What is neural network? The way our neuron works. How our brain comes to know what is happening. So continuously neurons will be flowing and providing the messages to the brain, and with respect to that, brain takes the decision. Then validation and then accurate decision detection at the end. So the role of IoT and the results has been generated through the model applied by me, 48% yield, and labor cost also reduced by almost 40%. So AI driven disease management. So these are again some of the algorithms. Now, the integration of convolutional neural network and machine learning and the IoT. Okay. So it overall this has been also I have tested, and with the federated learning, additional privacy has been provided. This combination also you can try it out. And so one more algorithm is there, LO. Hello algorithm. So we have now recently 11 LOV11 version also launched. So in your projects also you can use it. It is an advanced algorithm available, and most of the agriculture data set it can be applied. Now the new term is LLM. Have you heard the name LLM? Large language models. LLM. Still now you might be using ChatGPT or Gemini or DeepSeek. Huh? Again, whatever the data set they have, it was a limited data set, and now we are shifting. If you have used ChatGPT 2 years back, it was not generating the results properly. But if you are using the ChatGPT now, it is giving you the most of the time, 99% time, it is giving you the perfect answer. Why? Because large language models has taken into consideration. What is the how it has came into existence? Rather than relying on the single model, we will take a whatever the data set is available to us throughout the world, we are taking into consideration, and based on that entire database, we are trying to generate the image. For example, if I will tell my model to generate Rajnikant photo by using LOV11, result will not be appropriate. But if I am using the large language models, any image can be generated. Whatever query you find, with respect to that, it will generate the result. So, the decision support system for field prediction using AI techniques. Now we are focusing on decision support system because decision needs to be maintained. Okay. Analyzing the data, studying the things is of no use unless and until you are not making the decisions. If disease has come, what amount of spray you need to spray on the lips? In what quantity, for what time, and if repetition is needed or not. If any disease has been identified, how to recover it? Decision needs to be taken. That's why decision support system will came into existence. We have genetic algorithm and artificial neural network. The way our neurons work, similarly artificial neural network algorithms will work. What is genetic algorithm? Genetic algorithms. Some genes from the father and some genes from the mother has been transferred to a child. Then from child to a grandchild. Whenever we go to the doctor, he will ask whether this is any problem you have to your parents or the grandparents, that will come to us. So it depends on the same concept. See, whatever the algorithms we have in a computer, most of the algorithms are taken from our day-to-day life only. You take the example of any subject. Whatever we are doing in our day-to-day life, the same algorithms we are trying to apply over here as well. So genetic algorithms are available. So genetic algorithm has a weighted factor available. Continuously, randomly we are trying to find out the solution. We are changing the weights. And with respect to that, whatever the results has been generated, whatever the positive results we have, we will keep that. Whatever the negative results we have, we will try to skip it. Okay? And with respect to that, we will continuously try to acquire the new knowledge. Now, the most important factor is you have identified the disease, you have identified the machine, but the most important factor is your soil. If soil is not good, how any product will grow? So, soil management, that's why before the crop or the yield, we have various processes are available to make the soil compatible to take the yield. So, by referring the papers from 2021 to 2025, if you go across the various papers available, recent studies show that AI is being used in many ways to improve soil nutrition management in agroforestry. Okay. Recently, the integration of the three algorithms has been done, and the soil management on the improvisation of the soil Again, in soil also different parameters have been checked. What amount of parameters that soil has, and before the crop itself, if anything is lagging, you can provide it. So in a VIT we have applied random forest and gradient boosting together and achieved the accuracy of the 87%. Now again, most of the students generally ask this question, what happens if the accuracy comes below? See, whenever you come up with the hybrid algorithm or the novel algorithm, in a research community, it is not accepted that you will get the best result only. If your results are coming less, that also will be accepted by the research community. You need to try it. You need to try different algorithms and the different things. So, support vector machine has been integrated with the IoT. Then in the second, CNN has been integrated with the general machine learning. Then the combination of decision tree, CNN and IoT has been taken. And every time you might have observed that some amount of accuracy has been going here and there, but all the models have achieved the accuracy of the more than 80%. Then the next combination is random forest plus CNN plus time series models. In that model, accuracy of 88% has been achieved. Then we have nutrient prediction in soil giving accuracy. So these are the different combinations I have put it in the slide to show you that you can go with the any combination as per your wish. Now the next we have automated tractor. Automated tractor which can work on its own as far as smart agriculture is concerned. So it can do all the things on its own. And this is the machine, automated machine has been created in the VIT. You can see in the photo, it has been created which can do most of the soil testing and the crop testing on its own. Now, so today I have tried to provide you the insights of the different algorithms. Okay? And by analyzing, yes, the last part of my presentation. Okay? So listen carefully. So I have come across the various algorithms and I have taught you which algorithm you can use, which algorithm and the combinations you can use on a particular problem definition and what results it has been generated. So if this is the summarization in the last two slides, you can see which algorithm fits better to which problem definition. Okay? If you require, I will provide this presentation also through madam to you. Okay? So for example, random forest algorithms are basically used for the classification and regression models. Okay? So as far as agriculture is concerned, you can use it for the crop yield prediction and decision detection in a multi-structural data. And soil testing also it can be used. Then we have support a vector machine, and one by one all the algorithms has been used over here. Now the one more algorithm you can see is the ensemble methods. So what is the use of ensemble method? Every time data set will not be common. For example, I have a data set of your preliminary data. Somebody may skip some fields. Dummy entries will be there, null entries will be there. So ensemble data will balance your entire data set and convert it into a proper format. So when ensemble techniques are needed, when you have multi-crop classification, pest infection you have, you can use ensemble techniques. So these are the summary you have. Then we have light GBM, gradient boosting. So these are the reinforcement learning algorithm you have. XGBoost algorithm. It performs well on the complex data set only. If you have a complex data set, then it will perform well. So in a simpler world, I will tell you, if you have a normal data where fixed answers are available, go with the supervised learning algorithm or the classification models. If you have a complex data set available and the fixed solution is not available with anyone, go with reinforcement learning algorithms. What is clustering? Clustering algorithms. So whatever the training data set I have with respect to training data set, some regions has been created. How many clusters you want, that I will decide. For example, if I want to identify 3 fruits or 2 fruits, orange and mango. So cluster will be created based on your training data set. What will be the orange, what will be the mango. So when you will provide the next fruit to that machine, it will identify whether it is an orange or a mango, and with respect to that, it will be kept in a particular basket. Okay. So for that, now K-means algorithm and KNN. KNN is a supervised learning algorithm. K nearest neighbor. Now how K nearest neighbor works? First, I will analyze my neighbors. Everyone analyze its own neighbor, and the data will be circulated among all. And this way KNN algorithm works. And what is K-means algorithm? Now in K-means algorithm, K stands for cluster, number of clusters. So the different clusters have been created. Whenever new element will come, it will be drawn on the x-axis versus y-axis, and whatever the region it will come across, model will take the decision. For example, if I have a cluster, 2 clusters are available, and my new entry is coming outside the 2 clusters as well. So in that case, from both the clusters, we have a centroid, and from the centroid, Euclidean distance of a new entry will be calculated, and with respect to that, it will be kept in a particular. And then we have reinforcement learning and deep reinforcement learning. Okay, so AI is a superset of machine learning, and machine learning is a superset of a deep learning. Okay, so in a deep learning, we will try to analyze and learn the things on our own. Okay, in detail, learning will be done. In a machine learning, learning is available on the less amount. Whatever the task has been given, machine will perform that task. A limited set of tasks will be given to machine. If any new task will come, machine is not able to learn on its own. So that's why we require deep reinforcement learning over there. And we have agentic AI also. Okay, so agent-based models, agent will continuously work and continuously analyze the details, and it will be final. Okay, so that's it from my session. Email to me, and happy to help in any kind of research. Okay.
Thank you, sir, for your valuable words. If you have any queries, you can ask.
Good afternoon, sir. My name is Sudarshan Reddy, EC final student. Why do you choose random algorithm, sir?
Random algorithm, random forest, or you are talking about all the algorithms? Random algorithms?
Random forest.
Random forest algorithm. See, random forest algorithm is specifically used for the regression models. where decision cannot be predicted. Okay. Some examples I have put it you in the during presentation also. How many uh, how much percentage you are going to score in the next semester? Can you tell me? No one knows. Even you don't know. Huh? Getting? So such kind of problems we need to apply the random forest algorithm. Okay? Again, on the Google Scholar, you can go through my publications. Which algorithm will be best suited for which applications? AI algorithm for a decision making. So in detail, article is available. You can go through it, you can analyze it, and still if you have any queries, you can come back to me. Okay?
Thank you, sir.
Yeah. Anything else?
I request Dr. U. Jayalakshmi, Head of the Department, to felicitate the Chief Guest.